In this video, I'm going to talk about STP Uplinkfast. Let me to explain it. After that, we can talk about the configuration of the Uplinkfast. Here we have a simple scenario, includes switch 1, switch 2 and switch 3. Switch 1 is the root bridge, and because of that, both interface of switch 1 now are designated ports, and also here in the switch 3, we have one forward port and one blocked port. Let me to show you the status of our scenario now. Here in the switch 1, I'm going to use the show spanning tree. Show spanning tree first can show us that we have only one VLAN 1, and after that spanning tree enabled protocol is IEEE, means here now we use the traditional STP actually, and after that, as you can see, both gigabit 01 and 02 are designated ports. Why? Because this bridge is the root bridge, because it has the lowest MAC address in this scenario. After that, about the switch 2, this is the switch 2. Show spanning tree can show us that the gigabit 00 has designated role, and gigabit 01 also is the root port, and the gigabit 02 is the designated port. And after that, in the switch 3, show spanning tree can show us that gigabit 01 is the root port, this interface, gigabit 02 is alternate, and because of that the status of this interface or the state of this interface is blocked. Also gigabit 00, gigabit 03 and gigabit 10, all of them are designated ports. Now we don't have any problem. Because of that, the PC1 can send traffic to the server 1. For example, here we can use ping the IP address of the server 1, 10.0.0.4. As you can see, we have connectivity, and you know that the traffic can pass from this path, from the VPC1 to the switch 3, then from gigabit 01 to gigabit 02 of the switch 1, then from the gigabit 01 of switch 1 to gigabit 01 of switch 2, and finally to the server 1. Okay. Assume that now we experience a fail. For example, here with the link between the switch 1 and switch 3 fail, you know that here actually we experience a directed topology change. Because of that, it takes about 30 seconds to for example convert the gigabit 02 from block to forward. Actually here consider an access layer switch that has redundant uplink connection to two distribution layer switch. Normally one uplink would be in the forwarding state and the other would be in blocking state. If the primary uplink went down, up to 50 seconds, in some cases 30 seconds or 50 seconds could elapse before the redundant uplink could be used. Let me to show you first it here. For example, in this, if you want, you can enable debug in the switch 3, but let me to first send traffic from VPC1 to VPC to server 1, actually repeat with for example infinite repeat. Now here, now we have connection. After that, in the switch 3, if you want, you can enable a debug spanning tree. Okay, debug spanning tree, for example events, and after that let me to shut down the gigabit 01 of the switch 3 and also the gigabit 02 of the switch 1. Okay, in the switch 1, configure terminal interface gigabit 01, shut down. Let me first configure the same command on the switch 3, configure terminal, again interface gigabit 01, then shut down. Look at here, now I'm going to press enter in both switch 3 gigabit 01 and switch 1 gigabit for example 02. Let me to shut down the gigabit 02 in the switch 1. Okay, and after that we can verify the result, shut down, and then in the switch 1 shut down. Okay, in the switch 3 we have debug. As you can see, now new root port is the gigabit 02, and it should go to the listening state, and after sending or generating TCP trap for port gigabit 01, after 15 seconds we will go to the learning, and you know that after 15 seconds again we experience the gigabit 02 change its status to the forward. Let me to wait about 50 seconds and 15 seconds, and here now gigabit 02 is forward. As you can see, between this time, and this time we have exactly 30 seconds of for example time. And also in the VPC1, as you can see, we have this amount of timeout. It means that in the spanning tree protocol, in traditional spanning tree protocol, we have a slow convergence. Let me to enable again this link. After that, I'm going to explain what happened when we configure the Uplinkfast. Here again, I'm going to enable the gigabit 01 of the switch tree. This is the switch tree, and then let me to use no shutdown, and then in the switch 1 let me to use no shutdown. Okay, and now we can talk about Uplinkfast. We know about the slow convergence of the spanning tree protocol. We know about, for example, about the port fast, that we can enable the port fast between the access layer and also the PCs or the host. But what is the Uplinkfast? The Uplinkfast feature on Catalyst switch enables leaf node switch or switch at the end of the spanning tree branches, means access layer switch, to have a functioning, for example, a root port, while keeping one or more redundant or potential root ports in blocking state. Okay, when the primary root port uplink fails, another blocked uplink immediately can be brought up for use. It means that when the link between, when the, for example, primary root port, this root port fail, the other interface, the next interface can be instantly forward, okay, without creating any loop. But don't forget, it is not limited to only, for example, two link. Many Catalyst switch have two built-in high-speed uplink ports or gigabit Ethernet, for example. You might get the idea that Uplinkfast can only toggle between two leaf node uplink ports. This is entirely untrue. Uplinkfast keeps a record of all parallel paths to the root bridge. All uplink ports but one are kept in the blocking state. Okay, if the root port fails, the uplink with the next lowest root path cost is unblocked and used without delay. First, let me to show you the behavior of the Uplinkfast, okay, with a simple configuration. After that, let me to give you more explanation about the function of Uplinkfast. For example, for configuration of Uplinkfast, only you need to configure this command, spanning tree Uplinkfast, in the switch tree, in the access layer switch. That's it. Okay, let me to configure it. After that, we can talk about the other detail. Here in the switch tree, as you can see, with show a spanning tree Uplinkfast, we can see that Uplinkfast is disabled. By default, Uplinkfast is disabled. Now let me to enable it. A spanning tree Uplinkfast. This is the command that we need to use, but here we have one option, maximum update rate or max update rate. I will explain it, don't worry. Only now I'm going to use a spanning tree Uplinkfast. That's it. Now we have Uplinkfast in our switch. Here now we see a log. I will explain this log, but before talk about this log, let me to show you again. Do show a spanning tree Uplinkfast. Here, as you can see, now the Uplinkfast is enabled, and also a station update rate set to the 150 packet per second. I will explain them. Here, as you can see, about the VLAN 1, here we have interface list. Gigabit 01 now is in forwarding state, and Gigabit 02 is actually in the list. It means that when the Gigabit 01 fail, immediately Gigabit 02 can forward. Let me to show you what happened when we experience a fail in the root port, in the primary actually root port. Okay, let me to show you here. Now PC1 can send its traffic to the server 1 without any problem. Okay, and again I am going to shut down the link between the switch 1 and also the switch 3. Okay, shut down, and then in the switch 3 also interface Gigabit 01 shut down. Let me to show you what is happening when we shut down this two link. In the switch tree, as you can see, VLAN 1 new root port is Gigabit 02, and after that, as you can see, this interface moved to forwarding. Actually, here we didn't experience any listening or learning state, and in the VPC1, as you can see, we don't have any timeout. And it is a good news that we didn't experience any, for example, time for conversions for going to the next link. Okay, in the switch tree, as you can see now, do show spanning tree can show us that the gigabit 02 is up, but now